Hey everyone, my name is Nick Jackson and I'm in Professor George Stewart's June 2010 Fundamentals of Physics class section 1. The topic of this podcast is the conservation and transfer of momentum in an elastic collision. As we've learned this month, elastic collisions are collisions in which objects collide and bounce off of each other. Today, I will be performing a simple experiment that will emphasize momentum transfer as it is acted upon by outside forces in an elastic collision. All we're going to need for this experiment is a basketball, a tennis ball, gravity, and the earth. Now we all know that both the basketball and the tennis ball will bounce when dropped on a hard surface. This is because the ball striking with the ground is an elastic collision. Remember, elastic means that the objects collide and bounce off of one another. Elastic collisions can be explained by the law of energy conservation, which states that energy can neither be created nor destroyed, only transferred. Branching off of this, Newton's third law then states that every action has an equal and opposite reaction. So as we can see, if we hold them both at the same height, about 1 meter off the ground, and drop them, gravity causes them to fall, and the earth in response pushes back with an equal force, causing them to bounce back in the opposite direction. Simple enough, right? Well, for the sake of experimentation, let's see how the momentum transfers when we drop the basketball directly on top of the tennis ball for the same height. We notice that both balls bounce to a very low height. Now, watch the dramatic results if we place the tennis ball on top of the basketball and drop them again for the same height. It would be simple for one to assume that the balls would bounce to around the same height as they did individually. But as we can see, there was a significant increase in the smaller tennis ball's velocity and height after the impact. Why did the objects act this way? Well, to understand these results, we need to understand momentum. Momentum, by definition, is an object's mass multiplied by its velocity. The basketball contains about 9 times more mass than the tennis ball, and since we're dealing with gravity, we know that their velocities will be the same. Therefore, since momentum is mass times velocity, the basketball will have 9 times more momentum than the tennis ball. When the basketball is dropped on top, the tennis ball will hit the ground first, sending its smaller momentum upwards. At this moment, the basketball's large momentum is still moving downward. Since the objects are moving in opposite directions for this brief instant, the falling basketball's velocity is twice as much relatively to the upward moving tennis ball. Because of this, the basketball squashes out the tennis ball's momentum while losing some itself, and they both bounce very low. In the second scenario, the basketball hits the ground first, which then sends its large momentum back upward. Just like with the first experiment, the top ball's momentum is still moving downward at the same speed that the lower ball is now moving upward. Therefore, its velocity is relatively doubled. During an elastic collision, the object with the larger momentum always wins. And since we are dealing with a basketball that has 9 times the momentum of its counterpart, the tennis ball, and the tennis ball now strikes the basketball at a doubled velocity, all of the momentum from both objects is transferred upward to the tennis ball, and it actually ends up bouncing 9 times higher than it would have by itself. So what have we learned here today? If you're anything like me, you learned a little bit about momentum. Remember that mass times velocity equals momentum. So if everything else remains constant, a raise in velocity is proportional to a raise in momentum. Likewise, a decrease in mass is proportional to a significant decrease in momentum. And if these objects hit head-on, the velocity of the impact is doubled. This explains why the tennis ball shot off of the basketball with a high velocity. It just goes to show, physics can be exciting sometimes. Here's some references.